Okay, example 2. 6 green marbles and 8 red marbles are placed in an urn. They like to place things in urns in the book for some reason. Urns what they use to put the ashes of a cremated person in after they passed. I don't know why they choose to use an urn. I would put it in a...
put marbles in that. It's very
well, I'm guessing it's not a filled urn. It's just going to be like a decorative vase. But if I wrote the book, it would have been a bag instead of an urn. But oh well, I didn't write the book. So if I have the urn here, let's just say it looks like that, and we have 6 green marbles. 1, 2. That's too big. That's weird. All these marbles are different sizes. Let's try again. There we go, and we have 8 red marbles. There's our urn filled with marbles. Okay, we reach in, we cannot see the marbles. They all feel the same, they're all the same weight, they all are the same temperature. The only difference is the color green and red. Other than that, there's no difference. I reach in the urn, don't look, and pull a marble out. Okay? So the sample space of this urn is 6 green, 8 red. Okay, so there's 14 marbles in the urn, right? So the number we need, of what we need to get from our sample space, the information we need to get from it is how many outcome possibilities are there. So the fact there's 6 green marbles and 8 red marbles makes 14 different outcome possibilities. Even though there's only 2 possible things that could happen, green or red, there's actually 14 different marbles, so that makes 14 different outcome possibilities. Okay, now, it tells us that one marble's drawn and dropped back, and then a second marble's drawn and dropped back. Both marbles were red. That's similar to them saying we flipped a coin 3 times, got heads every time. I took a marble out, looked at it, it was red, put it back in. How many marbles in the urn?
14.
14, 6 green, 8 red. Do it again, pull the marble out, look at it, it's red, stick it back in. There's still 6 green and 8 red, right? 14 marbles. So, just because they tell me this, all that stuff there, it has no bearing on the next pick, right? I've still got 6 green, I've still got 8 red marbles. So when they ask you the probability of something, make sure you're not focusing on all this extra information in the middle. Just answer the question they're asking about probability. Another marble's drawn, what's the probability that it will be red? To answer that question, we simply have to know 2 things. How many red marbles are there? How many marbles are there? If we know those 2 things, we're ready to go. Now, if this had said one marble's drawn and not placed back in the urn, and it was red, and another marble's drawn, not placed back in the urn, and it's red, that matters because now we've got 2 fewer red marbles, right? So the sample space has changed, the number of red marbles has changed, that would matter. But the fact they're being dropped back, that's useless. So we want probability of getting a red marble in this problem. So the probability of getting red is there's 8 red marbles out of 14 marbles. Always reduce fractions to lowest terms, so 4/7 is the probability. I'm looking for fraction answers to probability right now. Do not give me decimals, give me fractions. Don't give me percents, give me fractions. And the fraction should be between 0 and 1. I haven't mentioned this yet, but if the probability equals 0, probability equals 1. 0 means never, 1 means always. Okay. For example, what's the probability of pulling out a marble?
Always.
14 out of 14, right? Because they're all marbles.
Well,
Depends
So,
how good your hands work.
well, we're assuming we can pull one out. Okay, what's the probability of pulling out a baseball?
Never.
0 baseballs, right? So the probability is 0. So never, always, but usually it's something in between. A basic proper fraction, small over big, most every time.